Greetings everybody. What this video is designed to do is show you how to do a one-way analysis of variance using SPSS. And this is the same procedure you will use to complete your analysis for assignment 3. The variables that we'll be using today are section, and section is labeled 1, 2, and 3. And if you go into variable view, what I've done is I've actually labeled those sections. You don't have to, but it will help you to interpret the data a little bit better. And then if we go back to data view, the other variable we'll be using is quiz 3. And so the research question that we would pose for this particular analysis is that, do sections differ significantly on average or mean quiz 3 scores? And so the null hypothesis would be that sections do not differ significantly on mean quiz scores. And the alternative hypothesis would be that sections do differ significantly on mean quiz 3 scores. So the first part of the analysis that we're going to do is we're going to analyze our data to evaluate the assumptions. And so if we go to Analyze and Descriptives and Explore, we can put quiz 3 in the dependent list, and in the factor list we'll put section. And the reason section is considered a factor is because it's a variable, but it has more than one level. So in this case the levels are 1, 2, and 3. In terms of the statistics, it's going to give us everything that we need. So there's nothing that we need to change or do there. We just need to make sure that descriptives is checked. And for plots, I don't like the box plots in particular. If you want them, you can leave that checked. I don't like stem and leaves, but I do like the histograms. And then I like to check normality plots, because what the normality plots do is that they yield the Shapiro-Wilks test. The Shapiro-Wilks test is a test of overall normality for each of our groups by the dependent variable, in this case quiz 3. And then we can click on Continue and then OK. Now you'll notice that one of the things we want to check is the numbers in each group. And so we have 33 for section 1, 39 for section 2, and 33 for section 3. And then for each section we get our descriptive statistics. We get our mean quiz score, quiz 3 score, we get the median score, the variance and the standard deviation, the skewedness and kurtosis values. And these are reported by group. So section 1, section 2, and then the same information for section 3. We notice that from our tests of normality that for the Shapiro-Wilks test that each one of these distributions is significantly non-normal. And if we were to divide the standard error into the skewedness, or the standard error into the kurtosis value for each one of these sections, we would probably find that those values would exceed, or at least some of them, plus or minus 2. And that's an indicator of significant or severe non-normality, either skewedness, which is peakedness, or kurtosis, which is, skewedness, which is the distribution is pushed to the right or to the left, and kurtosis is how peaked the data is. And so we see that our data is not normal for this particular analysis. So for section 1, we can see that it's very heavily negatively skewed. Section 2 is negatively skewed, as well as section 3. So our data is skewed and non-normal. So we're not going to worry about these plots here, but they just come with the analysis when you want to get the Shapiro-Wilks test. So now I'm going to do the ANOVA analysis, and I'm going to come to Analyze, Compare Means, and One-Way ANOVA. And in this case, I want, again, my factor to be section, and I want my dependent variable to be quiz 3. And under post hoc tests, I want to click on or check Tukey. The post hoc tests are designed to make comparisons if the ANOVA is significant. So for example, if the ANOVA results is significant, then the post hoc tests tell us which groups differ significantly from one another on the mean quiz 3 scores. And then under options, I click on or check descriptive statistics because I want the means and the standard deviations. I want to check the homogeneity of variance test because that's one of the assumptions that we want to check. And then I check the means plots. And then we'll go continue and then click on OK. So you can see that for each of the sections I get the mean and the standard deviation. The same thing that we got with the Explore analysis. And but this time we get the test of homogeneity of variances, the Levene's test. And so in this case, our homogeneity assumption is met because this value here, this significance, is above 0.05. So what this means is that the variances are not significantly different. So when you're reporting and writing your report on the assumptions, you want to go back up here and not only talk about that the data is significantly skewed, but you also want to report the results from the Levene's test and report that the data, however, among groups has similar variances. So if we look at the variance for section 1 is 4.438, section 2 is 4.4, and section 3 is 6.4. Those variances, even though they're not equal, they're not different enough to be significant. So that's the assumptions part. So now we can go back and look and interpret the ANOVA. This is your ANOVA summary table. This is the table that you will report and cut and paste into your results with when you write your report for assignment 3. Notice that the result is significant. So what that means is at least one pair of sections or groups differ significantly on mean quiz 3 scores. This does not tell us which means significantly differ. However, we have the post hoc tests which do. So this makes this post hoc test, the Tukey, makes all possible comparisons. So section 1 mean is compared to section 2, and the mean difference is 1.385 points, and so that result is significant. Section 1 is compared to section 3, and the mean difference is 1.394 points, and that result is significant. Again, we're using 0.05 as our comparison to determine if a result is significant or not. And then if we compare section 2 to section 3, that 0.009 mean difference is not significant. So then section 3 is compared to 1 and 2 again. Those comparisons are redundant. So when we look at this, we can see that section 1 is significantly higher than section 2. Section 1 is significantly higher than Section 3, but Sections 2 and 3 do not differ significantly from one another. And then we have the means plot. And the means plot tells us that Section 1 has a higher mean, of course, than Sections 2 and 3. So you can see why Section 1, the mean quiz score, is significantly higher than Section 2 or Section 3. And you can see why Section 2 and Section 3 are basically the same. They're not significantly different. I hope this recording has helped. Please let me know what questions you might have.